Myself Khushi Banerjee, and the subject name is Electronic Devices. Today's topic will be transistor operating modes. In the last class we have already seen the working of the transistor. Now the transistor operating modes, it is basically classified into three types, that is the active mode, saturation mode and the cutoff mode. In case of active mode, there are two junctions, emitter junction and the collector junction. In active mode, the emitter junction will be forward biased and the base junction will be reverse biased. Base collector junction will be reverse biased. While in case of saturation mode, the base emitter junction is forward biased as well as the base collector junction is also forward biased. While in the cutoff mode, both the junctions, that is the base emitter junction as well as the base collector junction, will be reverse biased. Now the transistor connection, that is if the base terminal is made common to both the input and output side, it is known as common emitter. If the emitter terminal is made common to both the input and output side, it will be known as common emitter. If the collector terminal is made common to both the input and output side, it will be known as the common collector transistor mode configuration. Now this is the transistor configuration for common base, in which we can see that is the base terminal is made common to both the input and output side. So in this case, when base is made common, the input current is IE, input voltage is VEB, while the output current is the collector current IC and the output voltage is VCB. It is shown for both the PNP and NPN configuration, where the emitter junction is being forward biased and the collector junction is being reverse biased. Now what is the current amplification factor? It is the ratio of the change in output current to the change in input current. As in this common base, the output current is the collector current and the input current is the emitter current. So the current amplification factor in common base, it is shown by the alpha, which is equal to delta IC, that is the change in the output current, divided by delta IE, which is the change in the input current at constant VCB, that is the collector base voltage. The practical values of alpha, it is less than unity, but its range is from 0.9 to 0.99. Now what is the expression for the collector current? We have already seen that IE equal to IC plus IB. The collector current IC, it is a part of IE, that is alpha IE plus ICBO, where ICBO, it is the leakage current flowing due to the magnetic area between the collector base junction. So the total current IC equal to alpha IE plus ICBO. From this expression, we can write IC is in relation with the alpha. Now this is the input characteristics for common base configuration. Now as emitter junction is being forward biased, this characteristic is similar to that of a forward biased PN junction. That is, with increase of input voltage, the value of input current, it will increase, which shows the value of input resistance being less. That is, i.e. it is almost independent of the value of VCB, that is the output voltage. It mainly depends upon the increase of input voltage. Now this is the output characteristics of common base configuration, which is further classified into three types, that is the active region, saturation region and the cutoff region. Now for the active region, we can see that it increases in as a straight line. That is the output current, it mainly increases when the value of the input current increases, while it is not increasing when the value of the output voltage is increased, which shows that BJT is a current mode configuration because the value of output current, it increases mainly with the increase in the value of the input current. While in the saturation region, both the junctions being in the forward bias mode, we can see it is going down towards the left of the graph. While the cutoff region, both the junctions being reverse biased, the value of current, it is below 0, that is both the value of the current, it is 0. So this is the output characteristics of the common base configuration, which is classified mainly into cutoff region, active region and the saturation region. In the active region, here we can see that is the value of the current, it increases as a straight line That is, with increase of input current, the value of the output current it will increase. Thank you all.